Hello guys, welcome to Code with BK. So in this video, we'll see how to check if an integer is a Kaprekar number or not. So again, in the first half, I'm going to explain the solution, okay? And in the next half, I'm going to explain you the code. If you're someone who's just looking for codes, there are links to the code attached in the description of this video. And to each code, there's a text explanation attached as well. So if you're somebody who wants to read and understand, you can take a look at that, okay?
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So what is a Kaprekar number? Suppose we have an integer k of n digits, okay? We square this integer, so square of k is k into k. You divide this square of k into two halves, okay? You separate the digits of the square of k into two halves. So square of k has the rightmost n digits are the right half and the remaining digits are left half. So suppose if square of k is of l digits, the rightmost n are the right half and the remaining are the left half. If you add these respective halves, if you do left half plus right half, and if this is equal to the original value k, then it is a Kaprekar number. So in our problem, we take a value k and print yes if it is a Kaprekar number, else we print no. Let's take an example for a Kaprekar number. If I have, say, 297, okay, this is 3 digits, okay. The square of this is 88209. We extract the right half first from the square of k because we have to find the rightmost n digits first. So rightmost 3 digits are going to be 209, okay. They form the value 209 and the remaining form the value 88. So if you sum 88 and 209, you get 297. So this is a Kaprekar number. Similarly, we have 55, square is 3025. You sum 30 plus 25, you get 55. Let's consider one more case for 1. So 1 square is 1, okay. Number of digits in this k is 1. Number of digits in this square is 1 as well, okay. So the rightmost n digits are going to be 1 and left half is going to be nothing. So we consider this 0. So 0 plus 1 is 1. So this 1 is also a Kaprekar number. Even though we don't get anything for the left half, we consider it 0. So this goes by definition for a Kaprekar number. You can Google what a Kaprekar number is, or there is a link in the description of this video that defines what a Kaprekar number is. So in the method that we use strings, I'll write a pseudocode function is Kaprekar number takes an integer k. This will return true if k is a Kaprekar number, else it will return false. Okay, the first task is to find the number of digits in k, right? That is the value of n. I've already posted a video where we find the number of digits in an integer. You can take a look at that. So n is number of digits in k, and since we are using strings in this, we can simply convert k to string and then find the length of that string. Okay, so we can say kstr is convert to string the value of k, and then n is length of kstr. Converting k to string, storing it in the variable kstr, and then finding the length of the string kstr, which is n, the number of digits in k. Then we find square of k. So square of k is k into k. That's very simple. Then we need to split square of k into right half and left half. Again, we convert square of k to a string so that we can easily split the square of k into two halves. For example, if I have square of k as 88209, right? So I can convert this into string, it becomes 88209, okay? I can use substring operations to find this and this. So converting this square of k to a string, square of k. Then we need to find the right half and left half. Right half first because right half forms the rightmost n digits. So for a length string of this length L, so L is basically your length of square of k string. L is square of k is L digits, so length of square of k is going to be L. So right half is n digits. So from this string of length L, we start from here, okay, and we have to extract rightmost n. So we can say find substring from L minus n. That is from this length, remove n and then give me that substring. So you can say right half is skstr dot substr starting from L minus n till end. Okay, so it starts, in this case L is 5, right, and n is 3, so 5 minus 3 is 2, so 0 1 2 you get substring starting from here, so you get 209. So left half is going to be, okay, left half is going to be starting from the first index, which is 0, so skstr dot substr starting from 0 till index 2, which was L minus n, till L minus n. So then what we do is, so you can call them as right half str and left half str, str and left half str, because these are currently strings, right? You are extracting the substring from a string. Then you convert them into integers, add them to check if they are equal to k, okay? Because after extracting the halves, we add them and we compare it to k. These are currently strings, so we have to convert them into integers. So I say right half is 2 integer right half string and left half is 2 integer left half string. So right half and left half are now integers. You have to just check if they are equal to k. So if left half plus right half equal to k, you print yes, else you print no. So this is how you check if an integer is a Kaprekar number or not. Let's try in this code. So our k example was 297. Okay, so k gets the value 297. So k str is string form of 297. So you get 297. Okay, in a string. N is length of k str, length of this string, which is 3. N is an integer in this case. Sk is square of k. So squaring k you get 88209. This is an integer, a square of k. Square of k string is 2 string, the square of k. So you get 88209 in a string. Okay. L is length of this string, so L is 5. Then right half string is skstr dot substr L minus n. L is 5, n is 3. 5 minus 3 you get 2. So dot substring from this index means you have to find the substring starting from this index till the end. So starting from index 2 till the end, you get 209 as a string into rhstr. Left half string is skstr dot substr, first index till second index. So 0 till L minus n, which is 2. So it means you have to start the substring from 0, go till less than 2. Start from 0, go till less than 2. This index is not included, okay, whenever you find substring. So you get 0 and 1, basically you get 88 in left half str, okay. Then you convert right half str into right half. So you get this string into integer, you get 209 integer. Similarly, you get left half str into left half, 88 as integer. Then you check right half plus left half, so 209 plus 88 is basically 297, which is equal to k, so you print yes. Let's take another example. If I have k as 1, k str is going to be 1, n is the length of k str is going to be 1, square of k is 1 into 1 is going to be 1, square of k str is going to be 1, length of square of k str is going to be 1. Right half string is skstr, which is this, dot substr L minus n. L is 1, n is 1, so you get 0. So basically you get the entire skstr string since you are finding the substring from index 0. So rhstr is basically 1. For lhstr, you do 0 till L minus n, so 0 till 0 for case of 1. In this case, you get a blank string because both indices are the same. So you get left half string as blank, okay? So when you get right half, you convert this into right half, you get 1. But when you try to find left half, you try to convert blank into an integer, which might give you an exception. So we can write a small if case. So if left half str is blank, okay, you set left half to 0, else left half is basically 2 integer of left half str. And this is because by definition, for a blank string, okay, for a blank left half, we need to consider this as 0 because 1 is our Kaprekar number.
So this is the implementation of the solution we discussed. So I've written a function is Kaprekar number that receives an integer k, returns true if this integer k is a Kaprekar number, otherwise it returns false. We start by converting k to its corresponding string and then finding the length of the string. So basically n is the number of digits in k. We find the square of k and then we convert the square of k to its corresponding string, and L is the number of digits in square of k. We find the right half first, okay, starting from the index L minus n, and then we find the remaining left half from index 0 till less than L minus n. So this second index, when we are finding the substring in Java, is not included. Everything from 0 till less than L minus n will be included. We convert the right half string to its corresponding integer. For left half, we check if left half string is not blank. So if left half string is blank, that is its length is 0, left half stores the integer 0, otherwise it stores the integer form of left half string. Finally, we sum the left half and right half and check if they are equal to k, we return true, otherwise we return false. In the main, I am testing it with integer 297. So let me run this. Alright, let me take another example. I'll change it to 55. Okay, compile, run. Okay, and then one final example for one where we have left half string as blank. Compile and run. It is true. Okay, so I hope this video was helpful. So please do like this video and subscribe to my channel. And please post it in the comments if there is anything not clear to you in this video, or if there is a concept you want me to discuss, or if there is a question you want me to solve. Thank you.